Good afternoon and welcome to the STS-34 Post-Flight Crew Press Conference. We're going to have the opportunity this afternoon to look at some slides and home movies and hear from each of the crew members. And following that, we'll take some questions from here and at other NASA centers. And with that, I'm very pleased to present Crew Commander Don Williams and the crew of Atlantis.
Thanks, Jeff. This was a great adventure for us. You guys have all met Mike McCauley and Franklin Chang and Shannon Lucid and Ellen Baker. Today, we're here to tell you about the flight from our viewpoint, the viewpoint of Americans in space.
The launch and entry suits that we use now are not trivial. We had about 15 or 20 suited evolutions sometime during our training so that this whole process on launch morning went very smooth and very clear. As you might look from the ground here, it's wet. This is our real launch day as opposed to the second one. We're still very happy, but we're looking at blue skies even though there has been rain. This next sequence is half speed, I believe. Main engine start, of course. And about this time, I turned to look at Don, and I said, "You didn't prepare me for this," as the tower went by a great deal faster than I thought it would, based on my simulator experience. $4.5 million pounds or so of machinery and 6.5 or so million pounds of thrust. The roll maneuver. There was a great deal more vibration here than I expected. And I think it's probably acoustic. It shakes your body and your soul. Not too far into the flight, the main engines throttle back, and as you reach maximum dynamic pressure, and there's some very good shots here of the waves created by the speed, the maximum dynamic pressure as we went through the area of max Q. And of course, SRB SEP, this is another area that Don failed to prepare me well for. In the simulator, there's a flash bulb or something that goes off when you get to SRB SEP, and in the real life, there's an explosion that goes off right in front of your face. It was wonderful, but it was surprising. Sort of like an 8.5-minute catapult shot.
Well, you get up on orbit, and then you look out, and this is what you see. You see the Earth going by, but you don't have a whole lot of time to look out the window. You have to get busy, and there's a tremendous amount of work that needs to be done to reconfigure the shuttle so that it's ready to stay up on orbit. And during the post-insertion time, we also had to get ready to launch the IUS. To launch an IUS, it takes all 5 of the crew members to do that. Ellen here is working, configuring the communications so that the IUS would lock up on the right frequencies. Franklin was busy downstairs. Franklin was sort of in charge of all our cameras, and he had to configure the IMAX camera to get it ready so that we could take the movies. Then we had to go back upstairs and get ready to launch the IUS. The first thing, a visual thing that we had to do was get the IUS up to 28 degrees, and that all went very smooth. And then we had to, we changed our positions a little bit inside the cockpit, and Ellen traded out with Don so that Ellen was sitting up in the commander's seat and monitoring the RTG purge, and Mike was orienting the shuttle so be in the right position, and Franklin was busy with the cameras, and then Don moved back to the back so that he would be ready to fly the shuttle away from the IUS as soon as we deployed it, and then I was busy at the IUS panel back there in the aft. Well, we went ahead and we did the RTG purge. We pulled the umbilicals and we raised the IUS and the Galileo on up to 58 degrees. Then we had a few minutes to sit there and wait until the proper deploy time came. The deploy time came, we flipped the switch, we deployed it, and it slowly went out of the payload bay. And at that time, both Ellen and I sighed a great sigh of relief because we figured Galileo was not our concern at that point because we'd gotten rid of it. And we also figured that happiness was an empty payload bay, and we got happier and happier as the IUS and Galileo went further away from us. and then Don was getting ready to fly the shuttle and maneuver it away from the IUS and Galileo stack.
Once Galileo was safely on its way, and they told us that it was doing pretty well, we got down to some other nitty-gritty hands-on science on board. The first thing that we had to do was to activate the SSBUV can, which was set up in the payload bay, and you can see how it opens a lid to expose the instrumentation on board to the Earth. We had to do this with very accurate timing, and with the help of the ground, we could know exactly when to expect the sunrises and sunsets that were important for this experiment. Shannon and Don were busy also setting up their apparatus for the student experiment, and this was another clear example of the importance of the human being working with experiments that have interactive capabilities. This is one where we used a lot of the fiber optics system to be able to diagnose some of the problems that occurred, and between Shannon and Don and the people on the ground, they were able to troubleshoot the problem, and eventually the two of them were able to get some very nice crystal formation of ice in the small filament inside the chamber. Shannon was also busy setting up for the PM experiment, the polymer morphology, from 3M Corporation, and that experiment worked pretty nicely. We had a little bit of an initial problem with it, but once again, with the help of the ground and working all together as a team, we were able to troubleshoot the problem and come back with some solutions for it. We had a very nice interactive computer keyboard that allows us to have some insight as to what was going on in the experiment. The GHCD experiment was also done later on, just before we came back, to be able to freeze up the state of the corn shoots before we deorbited. We did a bunch of medical studies. Ellen here is measuring the circumferential loss that I had in my legs due to the fluid shift to the top of my body. I lost about 2 inches on the upper part above my knee, and about 1 1/4 inches or so on the lower part below my knee. And it was almost immediate. It was rapid fluid shifting due to the weightless condition. Here's a very unique way in which you can do examinations on board of the eye with a human subject. The position is whichever way it works best for you. And these are some of the pictures that we downlinked almost live directly from the instrumentation that we were using. And Shannon is here measuring the carotid blood flow to Don's brain, and here in this case it is measuring just a little bit downstream of that flow coming into the brain. In the case the subject is myself. We did this kind of experimentation just about every day, and it worked pretty well.
Well, the equipment that everybody used and everybody was adept at was the cameras. Certainly one of the big bonuses of spaceflight is that you get to look out of the window. And these two windows, the overhead windows, were the prime real estate in their little crew module. Anytime there was a free moment, we would put our face to the window and watch the world go by, and it's a magnificent sight. We carry a variety of cameras normally, a few Hasselblads with a variety of lenses and a variety of different films. Some Nikons, again, variety of different films, variety of different lenses. We have the payload bay cameras, several different kinds of moving picture cameras, and occasionally a camera like the IMAX. So we're all studying to become adept photographers. And as I said, this was the prime real estate. Whenever it got a little bit dull or dark, we'd ask Shannon to put on her sunglasses, and they really brightened the place up. Again, you can see a lot of features from space. This is a dust storm. If you can look at the coast, you can see the dust streaming off the coast of northern Africa, the Nile Delta, the Sinai, the Middle East. Truly magnificent. And I wish I could think of the right words to describe it. And I'm certain almost everybody has said that same thing. And Franklin's old stomping grounds, again, we were really pleased that the weather was good over Central America. Franklin had told us we wouldn't see anything, and we were real pleased to be able to take some good shots. Had nice weather over the Caribbean. This is a shot of Cuba, and we'll zoom in now on Guantanamo Bay. But I was very amazed at the amount of detail that the human eye can see, and certainly with a 250 millimeter lens, you can see even greater detail. You can tell by the wobbling, it's hard to hold the camera still. It's easy to see the cities go by at night. It's sometimes hard to identify where they are. We need the help of our computer to do that, but the weather was also another really astounding thing. The enormity of some of the storms that we saw over Central America and Africa were really something. We did downlink that picture of the aurora in black and white, and we're very fortunate that Franklin was able to capture it in color. Again, the cameras are one of our prime piece of equipment, and we're all fairly adept at taking the pictures.
This next segment is about living and working in space. One of the two most frequently asked questions when we go out on the road and do public appearances, and the one that most school children have asked me anyway, is what's it like to be in space? What's it like? Unfortunately, this is probably one of the most difficult questions to answer, since the word like implies a comparison. And it's not like anything you've ever done before. So most of us are stuck with describing the differences. Yet, even there, many of the words don't exist to tell you the story. Weightlessness? How do you describe weightlessness when we live in a world where everything weighs something? The ability to move about almost by thinking about it? No up or down. Behavior and misbehavior of common ordinary things such as liquids, elastic, food, objects. Watch the video with us. Compare it to things you do on Earth. Look for the differences. Perhaps you can describe them to us. Eating is an adventure. It works fine in just about any attitude. It may look a little strange, but it works fine. Housekeeping is required. The ship doesn't run entirely by itself on computers and automation yet, so it still requires things like cleaning up, changing out the CO2 scrubber system for the air revitalization system. And the days come to an end, like days do here on Earth, although the sunrise and sunset still occurs every 45 minutes when you're on board. It comes time for the sleep period. Your clock runs to a different time than Houston time or New York time or California time or Tokyo time. But it comes time to go to sleep. These are the sleeping arrangements. It's a little bit like a camping trip, except you never get out of your camper for 5 days. So this is the good night, Mike. Good night, Ellen. The day before entry was somewhat interesting, in that all these suits that Mike described to you before the launch now have to be sorted out and climbed into on orbit. The reentry was spectacular, as I remember it before. A fire outside the window during the earlier part of reentry, a sense of tremendous speed as you travel across the surface of the Earth from 400,000 to 300,000 to 200,000 feet. The rush of the ground coming up as the spacecraft approaches the runway. The landing, much like the simulator, yet different, a very responsive airplane, a very real airplane, a real magnificent flying machine. The touchdown, the rollout, the nose wheel steering tests, and the end of an adventure for the STS-34 crew, one which we'll never forget, and we're happy to have a chance to fly with you, to share with you today. As you watch the end of this mission and the crew egress, all smiles on all 5 faces, as you might expect at this point. A very happy group. Greeting the Associate Administrator for Spaceflight, Dr. Lenore, and the NASA Administrator, Admiral Truly, who also seem very happy. A beautiful spacecraft, designed, engineered, built by Americans for one of the finest programs in the world today. We're very proud to be here and share it with you. We hope you are also. Thanks.